temperature, center line 400 to reach temperature, and the furnace gas temperature is capacity is only 100 watt per meter square, not more than 100. So it will release only maximum to maximum capacity of the fluid to convect is 100. So what does it mean? Some quantity, listen, some quantity will convect it out. As a result, what happens? The surface get cooled. But please try to understand. Now the surface reach 80 degrees Celsius. Now the surface reach 80 degrees Celsius roughly. Just I'm assuming. Now why it is like that? Why 80 only? Why not below 80? Why not the surface cooled below 80? Because the H is fixed. So what is H? H is 100 only. So the amount of heat convected is 100 watt per meter square. So there is a limitation. Let us imagine H is 1000. Let us imagine H is 1000. So suppose if H is 1000. Now suppose H is 1000 means it has a tendency to remove maximum heat, more and more heat. Then in that case, this is 70 degrees Celsius. Why 70 degrees Celsius? Because last time it is 80. Right now the H is 1000. So 1000 will remove from the surface. So surface rapidly get cool. As a result, it becomes 70. Now again, what you will do? Now let us make 2000. If you make 2000, again I will change this. If you make this 2000, then what I found? It is 65. Why? Because H increases. As the H increase, surface rapidly get cool. But remember one thing, it's a number. It has a capacity of 2000 watt per meter square Kelvin. Now next, let us imagine. This is I'm going to change. If this is change, this will be the change. So see, let us say this is 5000. Let us say this is 5000. Let us say this is 60. So please try to understand what I want to convey. As your H is more and more, then what happens? The difference between this TS. And T infinity will be lesser and lesser. So here I can say Q convection is equal to what? HAS TS minus T infinity. Correct? HAS TS minus T infinity. So let us say Q convection per unit area is equal to what? H TS minus T infinity. H TS minus T infinity. Now what I want to say, as your H tends to infinity, if H is more and more, then what happens? This TS minus T infinity, this tends to 0. So the logic is, as your H is very high, then the difference between surface temperature and ambient temperature is very less. It means what? When your H value is high, the surface rapidly get cooled. As a result, there is a very less temperature difference between TS and T infinity. So this is hypothetical, right? H infinity when TS minus T infinity equal to 0. If H is more and more, the difference between TS and T infinity will be less. So now you got this point. What I want to say, check here. What is the question? The question said that the surface of the shaft remain at the furnace gas temperature. Once again, the surface of the shaft remain at the furnace gas temperature at all the time after they introduce into the furnace. So indirectly in this question, what is given? The surface temperature and ambient temperature. Once again, you read this: surface of the shaft remain at the furnace gas temperature at all the time after they introduce into the furnace. It means it's a clear indication that in this case it's a clear indication that H is infinity. That's why the TS minus T infinity tends to 0. H is infinity. That's why the TS minus T infinity tends to 0. So this is the logic. Now you tell me, if the H is infinity, then what is Biot number? Infinity. And Biot number is infinity. So what is 1 by Biot number? 1 by Biot number is 0. 1 by Biot number is 0. After the introduction. Check here. What is the question? The question said that the surface of the shaft remain at the furnace gas temperature. Once again, the surface of the shaft remain at the furnace gas temperature at all the time after they introduce into the furnace. So indirectly in this question, what is given? The surface temperature and ambient temperature. Once again, you read this: surface of the shaft remain at the furnace gas temperature at all the time after they introduce into the furnace. It means
সো এইচের ভ্যালু যত ইনক্রিজ করতেছে তত আমরা কী করতেছি 50 ডিগ্রিজ করে অলমোস্ট 50-র কাছে পৌঁছে যাচ্ছে। সো টিএস আর টি ইনফিনিটি সেমই হতে পারে। তো এখানে যখন বলা আছে সারফেস ফার্নেস গ্যাস টেম্পারেচার, সারফেস অ্যান্ড দ্য ফার্নেস গ্যাস টেম্পারেচার রিমেন্স অল দ্য টাইমস সেম। তো সেম মানে কি? কখন সেম হবে? যখন টিএস ইকুয়াল টু টি ইনফিনিটি হবে। Okay, that's what it has been told.
it's a clear indication that in this case it's a clear indication that H is infinity. That's why the TS minus T infinity tends to 0. H is infinity. That's why the TS minus T infinity tends to 0. So this is the logic. Now you tell me, if the H is infinity, then what is Biot number? Infinity. And Biot number is infinity. So what is 1 by Biot number? 1 by Biot number is 0. 1 by Biot number is 0. So please take care of this. So what I want to say in this problem, Biot number infinity, and Biot number is infinity. So what is 1 by Biot number? 1 by Biot number is 0. 1 by Biot number is 0. So please take care of this. So what I want to say in this problem, Biot number infinity. So lump cannot be used. Okay, lump cannot be used. So this problem solved by Haisler chart. Okay, this problem solved by Haisler chart. So in this case, what is Biot number? 0. Okay, Biot number is 0. Please try to understand. Biot number is 0. Now see, this type of curves are there, but that curve is not given in the question, right? Not given in the question. In GATE they did not given this type of curve. Now what to do in that cases? Listen, what to do in that cases? How this question will be solved? So 1 by Biot number 0. Now think everywhere. What they asked? Center line temperature. So this is the discussion of center line temperature, and both have the same initial temperature. So now logically you observe this: Tc minus T infinity upon T naught minus T infinity. Check of shaft A. shaft A, the central line temperature here central line temperature same, initial temperature, ambient is same. So now logically Tc minus T infinity upon T naught minus T infinity of A is equal to what? Is equal to Tc minus T infinity upon T naught minus T infinity of B is same, right? So now hope you understand. And anyway, in both the cases H is infinity. If H is infinity, you can say 1 by Biot number of shaft A, 1 by Biot number of shaft A is equal to what? 1 by Biot number of shaft B. Correct? 1 by Biot number of shaft B. So this is the logic. Now center line, to find center line, right? So to find center line temperature, we need chart 1. Okay, we need chart 1. So let us draw the chart 1 roughly. So this is Fourier number, right? This is Fourier number. This is Tc minus T infinity upon T naught minus T infinity. Correct? So in between there are inclined lines are there. These inclined lines are what? 1 by Biot number. These inclined lines are 1 by Biot number. Now you check, in both the cases this temperature drop is same. So temperature drop is same. So if the temperature drop is same, so let us draw line horizontally. Okay, let us draw horizontal line. Correct? Next, in both the cases Biot number is same. So let us draw, this is the line. Correct? This is the line. In both the cases 1 by Biot number is same. Now you observe, in both the cases this value is same. In both the cases 1 by Biot number is same. So they have some common intersection. Now projected here. Already I told you, check Tc minus T infinity upon T naught minus T infinity is equal to what? Function of, check here, 1 by Biot number and Fourier number. 1 by Biot number in the Fourier number. Now tell me, if in both the chart, in both the shaft, if this value is same, in both the shaft, once again, in both the shaft, if this value is same, when you will get this value, when you have same Biot number and when you have same Fourier number, when this value is same, means this value should be T infinity upon T naught minus T infinity is equal to what? Function of, check here, 1 by Biot number and Fourier number. 1 by Biot number in the Fourier number. Now tell me, if in both the chart, in both the shaft, if this value is same, in both the shaft, once again, in both the shaft, if this value is same, when you will get this value, when you have same Biot number and when you have same Fourier number, when this value is same, means this value should be same. So check, when this value is same, this value should be same. 1 by Biot number already same. So what I want to say, your Fourier number of A should be equal to Fourier number of B. Then only you will get this value. So now let us come to this point. Let us take charts. Now imagine this value is a point 2. Right? Imagine this value is a point 2 for shaft A as well as shaft B. So this is the line, it intersects here. Correct? Now imagine in both the cases, see, check, 1 by Biot number is 0. So 1 by Biot number is infinity. So 1 by Biot number 0. So check, this inclined line also intersect here. Now if you observe, when this value is same, when you project it out, so Fourier number should be same. So that's the logic. So the logic in this, what is the logic in this case? In this case, the very, very important point is this one. When left hand side is same, right hand side should be same. So the Fourier number of A is equal to Fourier number of B. So that's the solution. So Fourier number of shaft A should be is equal to Fourier number of shaft B. This should be the calculation, right? Next, alpha A by TA upon LC square. Now it's a Haisler chart. If it is a Haisler chart, then no need of volume by area. You require just half of the dimension. So half of the dimension, this is RA whole square is equal to what? Alpha B by TB by RB whole square. Right? Now you can write like this. So I need a TB. So TB by TA. TB by TA is equal to alpha A by alpha B into what? Into RB whole square by RA whole square. Now what is alpha A? Alpha A is rho A. So listen, alpha is what? First I will write, this is K by rho C of A by K by rho C of B into what? Into RB whole square by RA whole square. So how you can? Write TB is equal to, how you can write? You can write here TA multiplied by, check here, check, you can write KA by KB. So listen, KA by KB into rho C of B upon rho C of A. You can write like this, KA by KB into rho C of B upon rho C of A into what? Into RB whole square by RA whole square. So now once again I will write this, TB is equal to TA into KA by KB into rho C of B upon rho C of A into RB RB whole square by RA whole square, correct? Right? Next, so TB is equal to, what is TA? If you read the question, what is TA? TA is 2 hours for first one. So keep as it is, 2 hours only you need to keep because answer should be in hours KA. So what is the table? Check what is KA, 40 and 20. So this will be 40 and 20. Now rho C, already I told you in the starting chapter, rho C is a specific heat capacity per unit volume, means heat capacity based on volume, or you may also call as volumetric heat capacity. Do you know? Already I told you rho C unit is joule per meter cube Kelvin. Check the unit, kg by meter cube, joule per kg Kelvin. You'll get this one. So see, rho C is given. What is rho C? 2 into 10 to the power 6. For shaft A, shaft B 2 into 10 to the power 7. So you can write like this. 2 into 10 to the power 7 by 2 into 10 to the power 6. Once again I need to cross check. Correct. Next. Into what is RB? Radius. But it given in the diameter. So what is the shaft B? 0.1. This is 0.4. So 0.05. This is 0.2. Radius. Next. So RB. So I will write here RB is equal to 0.05. And what is RA? RA is a 0.2. Just substitute there. Just substitute there. So 0.05 square by 0.2 whole square. Correct? 0.2 whole square. Just what you need to do now? Calculate. So calculate. If you calculate 2 into 40 into 20 into 2 into 10 raised to power 7 upon 2 into 10 raised to power 6 into 0.05 whole square upon 0.2 square. So if you solve this, you will get TB is equal to what? 2.5 hours. 2.5 hours. So this is the answer. See how beautifully they frame this question. So this is 2.5 hours, right? So this is the GATE 2016 question. This is GATE 2016 question. Already I explained so many things about this. Just secret is what? What is the secret in this case? The secret is H tends to infinity. H tends to infinity. Please try to understand. If H tends to infinity, the difference between surface and surrounding will be 0. Okay. So 0, right? So this is the way to tackle, and with the use of Haisler chart. Already I told you in this temperature ratio is same, then Biot number and Fourier number should be same. So once this Fourier number is same, then equate, you will get 2.5 hours. So please try to understand. This is the only one question asked in GATE examination, and one of the good question. I explained so many things. Sometimes I said so many things here and there, but please try to understand. This is the important topic. This is the important question. That's why I discuss so many things. So please listen and think on this. So there is a possibility of Haisler chart question, even though they will not give the Haisler chart. Okay, so don't underestimate the GATE candidate. They can ask anything. So what is our primary duty? To cover entire syllabus. Hope it is clear.